Okay, so we're going to do some DC simulation again here. The first thing we are going to do is look at a DC sweep on how to simulate a DC sweep for looking at a behavior of a diode. So we're going to simulate a very basic circuit here. So you might want to pause the video, draw this, make notes here or something of it. But this is the circuit we're going to simulate. And it's so simple that I'm not even going to need to have it redrawn and flip back and forth to it. So let me go back to capture. Now I'm using my capture version that's on my computer at home. Again, if possible, I'd recommend doing this in one of the labs like 211, 204, or 209. It's going to be faster, but you're welcome to use the Oporto as well. Okay, so let's do new project. And we're going to do PSpice analog mixed A and D. And I'm going to see here, where do I want to save this? Yeah, ECE 1000. This is when I taught it before, so there's already a lot of things in here. So I'll just create a directory and I'll say week 4, example 1. Okay, so I'm going to click OK on that. And then I'll just call this DC simulation. You might say we've done a DC simulation before, and we have, but this is where we're going to really do a DC sweep. So I'm going to create a blank project. And then what I'm going to do is make sure that you are aware of what libraries we need to have installed. And these libraries that you'll need to have installed will be the ones that you need installed to do the homework assignment as well. So I have a lot more libraries installed because I use this again at my at home, and so I use this, and again, I just have it all the time here. So you'll need the analog library installed. You'll need the diode library installed, and you will need the source library installed, as well as, apparently I don't have it installed here for some reason, I need my capsim. So I've got that installed now. So this example was very straightforward. I just had a resistor, and it was a 1K ohm resistor. Once this pops up here, and let me go ahead and zoom in. And then I have a diode, and let me just go ahead and go back here. So I said 1N4148. That is because that is the particular model number or part number for the diode. And if I go in the diode menu, it's probably, you can guess that that's where it would be. If I go to find 1N4148, you can see it's not there. But I believe, let's see if this works. I've not ever tried this. Let's use the wildcard by star and do 1N4148. I don't know if it does wildcards in here. It does, which is really nice. So 1N4148. So I did the star at the beginning, and actually if you wanted to be safe, I could just do the star at the end. Those are wildcards. So it's basically what it's saying. If you do a star at the beginning and the end, it's saying, hey, give me any part that contains 1N4148. Now, by doing that, I have more that showed up because there are particular ones. These are temperature ratings, and so basically this one here is operating at minus 55 degrees Celsius. This one's operating at 125 degrees Celsius. This is at 27 degrees Celsius. And there are actually different characteristics that happen when you do those. But we're never going to be that concerned about that in this course. And so I'm just going to do this one. Now you can kind of guess what's happening with all these part numbers. It's got a D in front of it. Let's don't think too hard. D stands for, what is this? Diode. So it's a diode 1N4148. And you can see it has the symbol, once I click on it, that I wanted to put in. Now I am going to go ahead and put in my source. And now if I click on the source, you'll notice that because I had typed something up here, there's nothing listed here. So if you delete out that information and hit enter, it will now bring up all of the source things. Or again, if you remember, well, I want VDC, it will go straight to the VDC, and then I can place this. Now I am also going to place my ground, 0 capsim. And now I'm going to go ahead and connect up all my wires. Let's go ahead and do that next. Now one thing you might ask me is, what do we set the voltage for? Because if you remember, here it says I'm going to sweep from 10 volts to minus 10 volts to 10 volts. And I don't want to necessarily say, okay, well, I want to start this. I mean, I can put negative 10 volts there, but it really is going to become useless. It's not going to matter what number we put here. I could put, just for fun, I'm going to put 10,000 in there. So this, in theory, says we're putting 10,000 volts there, right? Right? So we all agree that's, in theory, what it says, but it's not going to matter. And we'll explain why here in a second, because I'm doing a different type of simulation this time. So I'm going to go to my new simulation profile, and I'm going to say DC sweep, because that's what you can again call it anything you want, but DC sweep, I like to give it the name of what I'm actually doing. So I'm going to do a create profile. Now again, my computer runs a lot faster, and so it brings up here. Now what we're going to do here is we have to first change the analysis type here. See, this says time domain transient. I'm going to click the down arrow, click there. There's another one here, and probably can guess which one we're going to choose. DC sweep, because that's what we're wanting to do, DC sweep. Now this is where we're just going to do primary sweep. There's also secondary sweep. We're not going to get that into it that much here. And what we're going to do here is we're going to say voltage source here. And what voltage source are we going to want to sweep? Well, we only have one voltage source here, but if you had more than one, you'd have to specify it. And in this case, the name of the voltage source is just V1. So I'm going to sweep V1. Then I have to put a start value. Well, that was minus 10 volts. The end value is 10 volts, and then you have to give it an increment. And I didn't tell you what the increment is, but let's just go ahead and do 1/10 of a volt, just for fun. Actually, I hate the way I wrote that. I'm a big fan of always writing 0 in the front, because otherwise you lose the decimal point. So 0.1 volts. Now again, you could set it to be anything, but we're just going to do that for now. So I'm going to click OK. We'll go ahead and set some probes on here in a second, but I'm going to just run the simulation first. So run the simulation. My simulation window pops up. Now, as I said here, if you were ever to print these off or turn them in, like turning the graphs in, I don't want to see this black background. So let me show you how you can actually change that here. If I can remember how to do it. If I go to Tools, I believe it's Customize. Nope, that is the wrong one. Tools, Options. There are color settings here. It's not at all where you'd think it'd be. But color settings, background is black. So I'm going to say, well, I don't want that, so I'm going to change the background. Well, you could change to any color, but we're going to change it to white. Now the foreground, that's these axes here. It's right now this light gray, so I really want it to be on black. And then these trace colors, as a side note, this basically tells you the order of the trace colors that it's going to use here. And so you can also do like cursor settings, and this is what I'm going to do here. So the cursor setting, vertical line width, let's go ahead and see what happens when we oh no, that's the wrong thing here. I don't want to do the cursor settings. We'll just leave that for now. But that will change here. Suddenly you'll see I got a white background now and black font. All right, now you'll see the axis here, even though I don't have anything plotted, it goes from -10 to 10 volts. So let's go ahead and go back and measure something. So let's measure the voltage. Well, let's not measure the voltage. Let's measure the current, because we want to see kind of how the current is going through the diode. So I'm going to put the current right there, and then we can see I'm going to change the width of this again. We can see here that this is the thing, and we can see again, hey, almost zero current. And then once I start getting positive voltage, you can see, wait, it's not exactly when I have positive voltage, it's around that 0.6, 0.7 volts. Now, you might remember in my drawing, it went up straight like this. Well, the reason it's not doing that is because I put that resistor in there to resist the flow of current. So for fun, let's go ahead and take this resistor out and put a wire here. So now we're just going to do this, but then we're going to change my profile here, and I am not going to go to positive 10 volts. I am going to go to 0.8 volts, and we're going to go in an increment, and actually I'm going to start at, let's say, -1 volt, and we're going to go at an increment of 0.01 volts, and let's see what happens when we do that. So now I'm going to resimulate. And now you can see here, as I thicken this line up again, you can see here how we're getting that behavior, like I said, how that current is shooting up really quickly. And when I say really quickly, we're already at 35 milliamps. And if you want to see it go really, really quickly, well, let's just for fun, I say for fun again, let's go ahead and put that to 2 volts and see what happens. And we're now at 1.8 amps, essentially, or 1.7 amps at 2 volts. So it goes up. Actually, it's exponential growth is what happens. And that's why I put that current limiting resistor in, so we didn't get so much current coming out. All right, so let's go back here. I'm going to put the resistor back in, simulate it. Now, I want to show you again, we had set this voltage supply, this DC voltage supply, to be 10,000. But look, I went from -1. I forgot to change my simulation profile. Let me change it back to what it was. -10 to 10. I'll just leave it at 0.01. That's fine. I'm going from -10 to 10. That 10,000 has nothing to do with the simulation. So I could say 0.001 and it doesn't matter. You could even have this set at 0 and it's not going to matter, because whatever this set at is being overridden by our simulation profile, because we're doing a DC sweep. So it's a little weird here that you're putting a battery in here or a power supply and the value of it is completely irrelevant. And that's again because of the fact that we're doing a sweep. Now let me show you something else that I had a question on from somebody in the class. They're saying, well, what if I wanted to measure both voltage and current on the same graph? Because I said the problem is you know, it doesn't actually scale it properly, as far as like the units aren't really good on them. And so let's go ahead and do this here. So I'm going to do trace property here for this and just thicken this line up again. I guess super thick. And then I'm going to go to plot, and I'm going to say add plot window. So I've added a plot window here. Now first off, you see there's this SEL here. And if I click on the lower graph, there's an SEL. That's selecting what graph you're going to be plotting on when you connect a probe up. So if I were to connect a probe up here as far as a voltage probe to say, well, what's the voltage at this point here across this resistor? If I put that here, it's actually green, and the voltage across that resistor we can see goes from 0 volts up to almost 10 volts. And the reason it goes up almost 10 volts is that, well, if we go back to the circuit, this is again like 0.6, 0.7 volts. That is essentially always what this is going to be. And then the rest of the voltage has to drop across this resistor. So when you get more and more voltage, it's going to be there. Now, if you notice here, it's 0 volts though for a long time. Well, let's see, why does that make sense? Well, it makes sense because a diode, remember, it's a switch. It kind of turns on and off. And if it's off, no current can get through. If no current can get through, well, that means Ohm's law just tells me if there's no current going through here, Ohm's law would tell me that this would be 0. Now let me show you another set of probes here before we end this video. And apparently my brother is playing a game on Steam. If you are Steam fans, you can see that. Clearly I'm a Steam fan. This one next to the voltage level, this differential one. So this is actually how using if you're using a multimeter, how you would measure voltage. So what I'm going to do here is if I want to measure the voltage across the diode, first off, if I want to measure the voltage across the diode, if I click here and have that red line come up, and let me thicken that red line up. That's not the voltage across the diode. That's just the voltage at that point. That's the voltage at this point here, and that point is actually where the power supply is, so that should just go from -10 to 10. Well, yeah, it goes from -10 up to 10. Well, if I want to actually see what the voltage is across this diode, that's when I use this other set of probes here. It's called a voltage differential marker. And I put the plus, the first one's always whatever you want the positive side to be. So positive side, and then negative side. And now that one's in blue for me. And let me thicken that one up. And you can see that, well, wait, for the diode, when it's negative, there's -10 volts across the diode. And that's because the voltage has to be, quote, across something somewhere. And again, remember, it can make sense to have a voltage output, but just because you have something as an output as far as a voltage, if you're measuring a voltage across something, that doesn't mean that we have anything useful going on. It doesn't mean we have any power going on, because you can measure a voltage potential difference, but if there's no current flowing, then you're just measuring a voltage potential difference, and with no current, you're actually having no power going into the circuit. And then we can see that it comes up, and again at that 0.6, and you can see this voltage increases slightly because, yeah, it doesn't stay constantly at it, but it does increase a little bit. All right, so that's just some good information on how to do our DC simulation. So you're going to do a similar one here, but what you're going to do instead, I'll tell you right now, is you're going to do one, instead of using a diode like this, you're going to use a Zener diode, and you're going to see what happens with the Zener diode, and kind of see what happens with that. And remember, those are going to get plugged in backwards here. Let me see if I'm just going to show you one real quickly. This here, for instance, it's not the one that we're going to use, but this is a Zener diode. And actually, I'll go ahead and just plug this into the circuit real quickly here, just to show you this. If I were to plug this into this circuit, this isn't the one you're going to be doing, but if I were to plug it in the circuit, we actually run Zener diodes backwards on purpose. And so let me just resimulate it here for a second. I have no idea what this Zener diode's doing. And it went back to one plot here, so let me take this current away here. I have no idea what this part is, so let's see here. based off of this voltage. Let me take this one. Go away. Take this measurement off. And see. I can't see what it is. But in any case, this is how you would connect the Zener diode up. And so that will be something you'll explore in your homework assignment.